Example 2. We're going to draw some triangles on the Cartesian plane to prove the point that was just given on our sheet. So first thing we need to do is we're going to draw two terminal arms, one at 2, 3, 4, and one to negative 3, 4. Okay, let me create my grid here. So in quadrant 1, we have 3, 4. I'm going to do 3, 4. This is my terminal point. So I'm going to connect it to 0, 0. And from the initial arm, we have angle A. Now the second one we have is negative 3, positive 4. Negative 3, positive 4. Our terminal arm is here. Now I know that this is the large angle that it's created with the terminal arm. And in here, we have the related angle. I'm going to put A prime as the related angle, but you also notice that the related angle of both of these are the same. It's just a reflection on the y-axis. Okay, so drop a perpendicular to the x-axis. So I've dropped one perpendicular. I've created one right angle triangle. I'm going to use the related angle, drop a perpendicular as well. And we have also a right angle triangle here. I need to label my triangle, and they've told us that the length of the terminal arms are 5 units. So this is a 5. This is also a 5. And we're going to label the other sides of the triangle. I know that this is going to be 3 units because I know that I moved 3 units to the right and I had to move 4 units up. So our triangle is 4 units high. On the other side, we would have 3 as well, except since we're on the Cartesian plane and we're in quadrant 2, our x values are negative. So this is a negative 3, only to indicate we are left of the y-axis. And we have gone up by 4 units. Right, so find the primary trig ratios of each of the triangles. Let's recall SOHCAHTOA. This is going to be our memory trick for the trig ratios. This is my angle, so I have my opposite here. This is my adjacent, and this is our hypotenuse. Okay, let's write down our trig ratio. Sine A is opposite over hypotenuse. We have 4 over 5. Cosine A is adjacent over hypotenuse. And tan is opposite over adjacent. Opposite is 4 over adjacent, so we have 4 over 3. Let's look at the other side now. Same thing, we're going to use SOHCAHTOA, except our angle is going to be A prime. Sine of A prime is opposite over hypotenuse. So we have 4 over 5. Cosine of A prime is equal to adjacent over hypotenuse, negative 3 over 5, and tan of A prime is equal to opposite over adjacent, 4 over negative 3. Now what you notice is these numbers are all the same, but the signs are a little bit different. So I'm going to be able to, I can create a conclusion. When we have related angles, we're going to have numeric values that are the same, but the signs could be different. Now, what we call the numbers or the values, we call it absolute value. Absolute value just means looking at the number and ignoring the sign. So one conclusion that we can make is the absolute value of the trig ratios are the same for all related angles. Okay, second conclusion that we are going to draw is that for our Cartesian plane, we can say in quadrant 1, all trig values or all trig ratios are positive. So you'll notice here, we did sine of A. A is in quadrant 1. We had positive 4 over 5, positive 3 over 5, positive 4 over 3. Now, on the other hand, in quadrant 2, sine is the only positive one. Cosine and tan are negative values, and it's always going to be that case because our x value, or the adjacent value, is always going to be a negative in quadrant 2. So I could say sine is positive, cos and tan are negative.